A 3x3 system. This first problem on the homework is just me asking you the question, is this a solution to the system? And again, it's a solution to the system if it works in all three equations, meaning it makes all three equations true. And so the blue is me plugging into the top, the green to the middle, and the red is the bottom. And again, I'm just plugging in this point, and it makes three true statements. So yes, it is the solution. Here's kind of a picture view of these three planes. Again, this equation is an equation of a plane rather than when you have a 2x2, it's just two lines. Now we have three planes. And again, most of the time we have a situation where the three planes will actually intersect at one point. However, we can have no solutions where the three planes are parallel, or they look like this, where we have two parallel planes intersecting and they don't work in all three. We can also have infinite number of solutions where all three are the same plane, or all three planes intersect and form a line. Again, most of the time we're looking at this situation here where we're getting one particular solution. All right, here's the step-by-step directions, and on my key, I do blue, red, green, orange, purple. So if you look at this first one, I took the top two equations with my blue and I said, all right, let's eliminate a variable, and I happened to eliminate x. So I looked at 3x here and negative x here, so I'm looking at those two, and I decided that if I wanted to eliminate x, I would multiply the bottom equation by 3, thus setting up elimination. Okay, so that's me doing this right here. I multiplied the bottom equation by 3, I rewrote the top equation, and then I add equations together to get the blue. Then I picked two other equations. I picked the middle and the bottom equation, and I also have to eliminate x. So I multiplied the top equation by 5, getting negative 5 and 5. So I get these two guys, and I added the red equations, and I got the red, which also eliminated x. So now you look here, and I got blue, and I got red, and neither of them have x's. At this point, it's now just a 2x2. I just have two equations and two variables, y and z. It looks like in this scenario, I wanted to get rid of y, so I multiplied the blue equation, right here, by 9. 7 times 9, 8 times 9, negative 13 times 9. I multiply this equation by 7 times 7 times 7 times 7, and I wrote those two right here. I did that because I wanted to make sure I got rid of y, so I got a 63y and a negative 63y. Then I added equations, which eliminated y, and now I have negative 2z equals negative 12, and I can divide and get 6. Okay, so now I have one of the equations. Then I took this 6 and I could have plugged it in here, or here, or here, or here. Any of those values would have worked. It looks like I went up to this guy here and I plugged in z equals 6. So this is 9y minus 10 times z, right here. That's 60. Add 60 over here to get 45, divide by 9 to get 5. And then I can take these two values of z and y and I can plug in wherever I want. It looks like I went into the top equation. All right, so if you plug into the top equation, I know that z is 6, y is 5, and then I can solve this for x. And then I have an x value, a y value, and a z value. And I'm going to do the same process on every one of these. So if you scroll on to the next one, here's the next one. It looks like I took the top two equations in blue and I got rid of the y value. So if you look here, this is a 2y and a negative y. So I multiplied this by 2, changing it to a 4, a negative 2, a 6, and an 8. I didn't do anything to the top equation, and I get this, and then I can add equations. When I add equations, I get rid of y. Okay, so I have an equation with x and z. Then I took the bottom two equations, and I still want to get rid of y, so I multiplied the top equation by negative 3. So negative 2 times negative 3 is negative 6x. That makes that a positive 3y, it makes it a negative 9z, and it makes it a negative 12. I didn't do anything to the bottom equation because it was already how I wanted it. I added equations, and then I get an equation with x and z again. Then I take the blue and the red, and I decide what variable I want to get rid of. I decide to get rid of x. So I have a 7x and a negative x. So I need to multiply this by 7. So I don't do anything with the blue, I just copy it here, and I multiply this equation, right here, that guy, by 7. So negative 7, negative 28, negative 91. And then when you add equations, you can get rid of z. And then I do the same thing. I take z and I can plug it in here or here. Looks like I plugged it into the red. And I solve for x. And then I know z and I know x, and I can plug it in. I use the top equation up here. I plug in x value of -3, a z value of 4, and I found y. And then I have my coordinate system, or my coordinate point that works. And again, you can always check this coordinate point better work in the top, middle, and bottom equations. All right, one more. This one's actually super easy because it turns out that the top equation and the middle equation end up giving you instantly a no solution, which means those two planes are parallel. And if you look at it, if you multiply the top equation by -3, if you were trying to eliminate x, you'd get gone, gone, and you'd get 0 equals 8, which is a false statement. A false statement leads to a no solution. These two planes are parallel. If you look at the ratio of all the x's and all the y's and all the z's, they're all just 3 times each other, which really means they're the same plane with a slightly different distance from the origin, which does lead to a no solution. So you'd be done. Same thing here. I took the top and the middle, the top and the bottom, and it looks like I was eliminating z. See how this is a negative z and this is a positive z? So I don't even have to do anything to the equations. I can just add the equations as is and get rid of z. And then I took the middle equation and the bottom equation. I have a 2z and a positive 1z. So I'm going to multiply the bottom equation by -2, which gave me this guy. And then when I add them, I get rid of z. So I have an equation with x and y, and another equation with x and y. And you look at those for a second, and it's actually really easy because you already have a plus 8y and a minus 8y. So you don't even have to multiply anything by the blue or the red. You can just add the blue and the red, the y's will go away, and you're going to get x. Once you know x, you can plug it back in here to find y, or it looks like down the orange is me plugging it in here to find it. And then I find y, and then I know x and y, I can go into any of the equations. It looks like I went to the top equation, and I plugged in for x, I plugged in for y, and then I found z. And then I have my coordinate system. Same thing here. 2 equations, middle and bottom to eliminate x, top and bottom to eliminate x. Use these two to eliminate, it looks like y, get z, get y, and then get x. Okay? So hopefully this video helps, but again, it's the same process every single time. You are always going to just take a 3x3 and eventually change it to a 2x2. It doesn't matter what variable you eliminate, just pick the easiest one to eliminate, and then pick the next easiest one to eliminate once you break it down to a 2x2, and then you plug back in systematically to find the remaining variables.